Hello, this is Schedulytics and welcome to today's session. If you are new to the channel, we encourage you to click on the subscribe button, turn on the post notification bell so you are always notified whenever we release a new video. And if you're a returning subscriber, we so much appreciate you for patronizing our videos. And we encourage you to keep liking and sharing the video so all can enjoy this statistical journey. In today's brief video, we will be looking at analysis of variance, in short, ANOVA. Now, one will be interested in running ANOVA when he or she wants to compare or see whether there is a difference in a continuous variable, that is the dependent variable, among a categorical variable that has more than two categories. So example, you want to see how systolic blood pressure, which is the dependent variable, vary between marital status, which is a categorical outcome, variable with categories like married, single, divorced, widowed. So because the categories are more than two, and we are looking at a continuous variable, its difference among these categories, the best to choose is ANOVA. Now, there are some assumptions that one has to take into consideration when running ANOVA. First of all, the data sets, the dependent variable you are using or the continuous variable that you are using should be normally distributed. So obviously you want to check to see if it's normally distributed by checking the normality test. Second, you also want to see if the equal variance assumption is also not violated. And that is the Ballet test for equal variance. So once these two assumptions are okay, then you proceed with the ANOVA and you go ahead and run it. In the absence of the fact that it is normally distributed, you may want to fall on the non-parametric equivalent, which is the Pascal-Wallis test. And we will discuss that in our subsequent video. So be on the lookout for that. Now, let's go and use the STATA platform to run this one with ANOVA or the ANOVA analysis. So we are going to go to STATA and then we go to the command window. And we want to see how systolic blood pressure varies between the categorical outcome marital status. So first of all, we want to see what the categories are for marital status. Yes, so we have single, married, widow, divorce. So this is more than two. So it qualifies for ANOVA. Now, to see how systolic blood pressure varies in these categories, we equally want to check the normality of the outcome variable we want to use, which is what? Systolic blood pressure. So we locate systolic blood pressure, SBP, and then check if it is normally distributed. Yes. So S weight. And because the p-value here is not statistically significant, then it means that our systolic blood pressure here is normally distributed. So we fail to reject the null hypothesis that it is not different from a normally distributed data. So we have passed our normality test, and so we can use the ANOVA to run it. So we go ahead and type one way, and then we are interested in what? SBP, which is systolic blood pressure, and we want to see whether it varies with marital status. And then we click on tab, marital status, comma, tabulate. So we click on it, and right straight here we have our outcome. Here it gives us the marital status and a summary of the systolic blood pressure. So we have single, married, widowed, divorced, and these are the mean and then the standard deviation as well as the frequencies, and the totals are presented below. So between the groups, what is the SS? Within the group, what is the SS? This is presented, but our main focus is on this one. So the p-value for the ANOVA analysis shows that there is a difference in the mean of systolic blood pressure among the marital status of the individual participants of this particular data set. However, where the exact difference is, we cannot tell. And that is where we need to fall on the post hoc or post estimation analysis or tests, which we will talk about mostly in subsequent videos. So be on the lookout for those particular videos where we'll be discussing post hoc tests like Bonferroni, SIDAC, Shippey, Tukey, students, or DUNET tests, and so many more, the student Newman test, and so many more. So be on the lookout for those particular videos on this particular channel. Now, the second assumption check, which is the valid test for equal variance, also here has also been passed because our p-value here is not statistically significant. And so we can say that our valid data set has equal variance, or our categories have equal variance. So the two assumptions: one, normality test, which has been established here as being normally distributed. So we passed that normality test, and equal variance assumption test too, we have passed. So because we have passed these two tests, we can run the one-way ANOVA and we will not have any issue. And then our p-value here tells us there's a significant difference in the mean of our systolic blood pressure among the various categories: single, married, widowed, and then divorced. But as to which pair causes the difference, that is what the post hoc estimation test will tell. So basically, this is how to run ANOVA in STATA, taking into consideration the two main assumptions which must be passed before we run the ANOVA. Otherwise, we consider the non-parametric version, Puskar-Wallis. Until we meet again on our next one, this is Schedulytics, and it is a bye.